is a liquid. This is a gas. And this, well, this is a solid. Now, the amazing thing is that they're all made of the same stuff. Now, what is this stuff? Well, stick around.
Bill Nye the Science Guy. Bill Nye the Science Guy.
Science rules.
Bill Nye the Science Guy.
Inertia is a property of matter.
Bill Nye the Science Guy.
T minus 7 seconds.
Bill Nye the Science Guy.
Bill Nye the Science Guy is brought to you by matter. Matter is everything and all stuff. Stand by for matter.
Ever wonder what the universe is made of? Well, the universe is made of matter. And matter is stuff. Everything that you can touch is matter. And matter comes three ways, what we call phases. Matter is either a solid, a liquid,
It's liquid.
or a gas. That's what those bubbles are. Matter can be very refreshing.
That is molten steel. Now, the only difference between molten steel, melted steel, liquid steel, and solid steel is energy. That's right. The atoms in solid steel are moving a little more slowly than the atoms in liquid steel. Kind of wild. The gas in our cars changes from a liquid we call gasoline to a gas, to a vapor. Our cars run on a gas. A gas. The balloons are filled with a gas. Solid, liquid, gas, they're all phases of matter. It's chemistry. You just mix in a little energy and, you know, we should be in the lab.
The what?
The lab. No, where's the lab? Anybody seen the lab? We need to go to the lab.
Oh, here it is.
Getting things to change phase takes energy. So take a look at this. It's liquid water, and we're heating it with energy from this burner. Above the liquid is water vapor. It's invisible. The molecules get more energy, and they change phase to a gas. See, the liquid is becoming water vapor. It's changing phase into a gas. Now, what if we wanted to change phase again? Like, let's say we wanted to turn this liquid into something else. Like, maybe we want to turn this liquid into a solid. Now, how would we do that? We'd have to take energy away, right? What do you think we'd need? Well, maybe a freezer. Maybe a great big stainless steel freezer of science, like this one. Take a look inside. It's cold. It's real cold. Oh, it's like -4 degrees Celsius. Now, where does the energy go? Where does the heat go that was in this freezer? You can't just throw it away. That would be a violation of the first law of thermodynamics.
What?
Now, the heat has to go someplace. Well, take a look up here. See that thermometer? It says like 28 degrees Celsius. That's warm. That'd be like a very warm summer day. So what the freezer does is pump the energy, pump the heat from out of the freezer into the room. Now, if you can do that enough, you can make things change phase. Take a look at this. It's a great big popsicle of science. Solid ice. We changed the liquid from that mold into a solid. Made it into this popsicle. Oh, that's a good one. That's a real good one. Phase change. It's great fun at parties.
Changing a solid to a liquid to a gas always requires the same thing.
Pure energy.
And you can change a solid to a liquid to a gas just by taking some ice cubes out of the freezer and frying them up.
Here's some fried ice that we prepared earlier. Not bad, eh?
There's nothing there, Martin.
Well, of course not, Michaela. You can't see water vapor.
Then why don't we show them something they can see?
Good idea. Hit it.
Careful.
Ooh, ah, ooh, watch it. Oh, ah, ooh, 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 ah, ooh, ah. Oh, ah, ooh. Watch it.
some pretty excited molecules, huh, Martin?
I'll say. They were so excited, they vaporized.
Steam, you can see, is made of droplets, liquid water. When it disappears, it's an invisible gas, water vapor.
And you can make fried ice at home, too. Just make sure you have adult supervision so nothing gets overcooked.
See ya.
Energy can make things change phase. Like, this burner is providing energy that makes this liquid water change to water vapor. It's changing phase from a liquid to a gas. Now watch this. This is liquid nitrogen, and it's going to change phase too. I'm going to pour it into this flask, and it's changing from a liquid to a gas without the help of a burner. It doesn't need it. That's because it's so cold, minus 196 degrees Celsius, that the energy in the room is able to make it boil. This stuff looks kind of dangerous, doesn't it? But it's nitrogen. It's the same gas that's between you and the television. 78% of our air is nitrogen. So, the heat from the room makes the molecules move faster and faster, and they get farther and farther apart. And they change from a liquid to a gas. Now, what happens when molecules slow down? Well, they get closer and closer together, and some unusual things can happen. Here, let's try something. We'll take this, it's a rubber ball, this, ordinary onion, and a few of these, marshmallows. And we'll put them in liquid nitrogen and let them cook for a while. Come back in a couple minutes and we'll see what we get. If you just joined us, we've been cooking with liquid nitrogen. Liquid nitrogen is minus 196 degrees Celsius. It makes molecules slow down and get closer together. Here, watch. It's an ordinary rubber ball. Here's an onion. Oops. Liquid nitrogen gives you an unusual way to slice it. And these are marshmallows. They've been cooking for a while. You don't need a campfire.
Careful.
Oh, watch it. Oh, ah.
So now you know the three phases of matter. Solid, like this ice. And liquid, like this water. And gas, like this water vapor.
Here's the story of Johnny Atom, who is everywhere and everything we know. He is solid, liquid, gas, every matter. That's how the phases go.
Here's the story of the same guy, Johnny. He makes chemistry and science really fun. He is all things, he's all around us. He's the atomic one.
Energy and Johnny Atom work together, making all the matter change from state to state. Molecules, compounds, and even plasma. It goes to show you chemistry is really great. He's Johnny Atom. He's Johnny Atom. He's solid, liquid, gas. He's everything.
Welcome to the absolute zero hour. Now, we're not going to reach absolute zero, and it's not going to take an hour, but it's kind of a cool name, isn't it?
Okay.
Now, cool is just what I want to talk about today. See, this is a box of ice water. It's as cold as when you put ice in a soda. And here is a ball filled with air, and it's connected to a pressure gauge, an absolute pressure gauge. So the higher the pressure in the ball, the higher the gauge will read. You know, what's pressure? Well, it's like moving molecules. The faster the molecules are going, the higher the gauge will read. And the slower the molecules are going, the lower the gauge will read. Okay, I'm going to move the ball from here to here. Now in here we have dry ice. That's solid carbon dioxide mixed with a little alcohol, so it's still a liquid. Now this is colder than it is anywhere on Earth. This is colder than it is in Antarctica. It's colder than the South Pole. You see the molecules slow down and the gauge reads a lower number. Think of it this way. Here's the old molecule machine. Think of these plastic balls as molecules. And when the machine is going this fast, that's like ice water. So this is like a pressure gauge. And it reads this high when it's in the ice water. Then, when I lower it here, that's the pressure of the dry ice bath. So you see, the slower the molecules are going, the lower the pressure reading. Well, let me ask you this. Suppose there was no motion at all. Molecules completely stopped. Absolutely stopped. Well, that would be what scientists call absolute zero. It would be colder than almost anything you can imagine. And the reason is there'd be no molecular motion whatsoever. So try this. We're gonna put the ball of air of science into this special freezer. We're gonna imagine that it's gonna get very, very cold. Now, could we get to absolute zero? Actually, no. Absolutely no.
What?
If you called a travel agency and said, hey, take me to absolute zero, they'd have to go, we can't. You can't get there. Absolutely not. Isn't that weird? No, why is that? Think of it this way. Here's the ball of air, right? It's pretty cold. It's connected by this tube to this clamp. And this clamp is connected to the base of this refrigerator. And the refrigerator's on the table, and the table's on the floor, and the floor is in the building, and the building is on the earth. So there's always a path for heat to get from the earth, into the building, up onto the floor, up to the table, into the freezer, down this rod, into the ball of air. There's no way for the ball of air to be completely separated from some source of heat. There's always a way for heat to get to the air. You can never quite get to absolute zero. So you can't ever get to absolute zero. Zero! Scientists have gotten within 1,000th of a degree Celsius, but they've never gotten there. And they never will. Absolute zero. Zero is more of an idea than a real thing you can get. We can get within 1,000th of a degree, but we can't quite get there. There's no way. Absolutely no way. But the idea is kind of cool, isn't it? In fact, very cool. Thank you for watching the Absolute Zero Hour. That's a solid.
Solid.
Here's a really neat experiment. You'll need a jar that can take boiling water to do this phase change, like maybe an old jelly jar. In here I have a cup of boiling water and 2 cups of sugar. Now I'm going to pour the sugar water into this jar.
Whenever you're using a stove, be sure to have an adult around.
Careful.
Watch it. Watch it.
Now I've tied a piece of string to a pencil and I'm going to set the pencil in the jar like this. And that's it. I leave everything sitting here until it cools down. Then later I cover the top with plastic wrap and put it where it won't be disturbed. Rock candy. It used to be a liquid and now it's a solid. You can even add food coloring to make them any color you like. Sometimes science is very sweet.
This is solid carbon dioxide. We can change it into a gas immediately by putting it in warm water. Watch. Solid. Changing phase from a solid to a gas, which is pouring out of the spout of the pop bottle of science. And we apply the balloon, and it inflates rapidly. That's carbon dioxide gas. Not bad, huh?
It's a gas!
I'm Maggie Steen, and I'm a quality control scientist for Coca-Cola. And it's my job to make sure there's just the right amount of fizz in this can. We make 1,450 cans a minute on this line. This is where we keep the CO2 in the silos. It's a liquid form here. It's kept under high pressure so it stays a liquid. It goes through the heaters. It becomes a gas where then it goes into the filling system and it gets in our cans of pop. we shake the bottles and we test the pressure and the temperature, and with the temperature and pressure we can look on a CO2 little computer that we have and tells you the actual volumes of CO2 in there. If there's no carbonation in there, it's really flat. It's lost all its pizzazz. There's no point in drinking it, really. I mean, I think people drink it because it's carbonated. So I've been here 16 years and it's still fascinating.
Solid, liquid, gas. 3 phases of matter. Solid, molecules are moving slowly and packed close together. Solid. Liquid, molecules are moving a little faster. They're able to flow a little bit.
It's liquid.
Gas, molecules are moving very fast. They're just wild.
It's a gas!
3 phases of matter.
When matter is a gas, a lot of the time you can't see it. It's invisible. But here's a way to prove to yourself and any of our fellow scientists that invisible gas is matter. We'll weigh it. First, take a look at this broomstick balance of science. It's a broomstick with a hole in it. There's a lunch bag tacked to each end. Now we need to make some invisible gas. This is an old trick, but it's a good one. Pour some vinegar into a pitcher. Then add a little bit of baking soda. That fizzing is carbon dioxide gas coming off. It's the same gas that bubbles out of our soft drinks. Even though it's invisible, you can still pour it just like you pour water or milk. Pour the invisible gas into one of the bags. It pours even though you can't see it. The gas is heavier than the air and the bag on this end goes down. It's invisible, but it's matter. It's in the phase of matter that we scientists call gas.
It's a gas!
And it's total science.
Okay, today we're going to be working with some molten wax.
Looks just like chocolate.
And I'll have one of you pour that in for us. Aha!
Phase 1. The wax goes into the mold.
Okay, now we're going to let that cool. Okay, now that the wax has gone to a solid, we can lift it out of the pattern. Pop it. And there we are.
Oh,
We've got our pattern.
That's neat. What do you need the water for?
We're going to mix that with the plaster and sand.
Oh.
This is going to get rock hard in about 15 to 20
Is this
minutes.
like cement?
Like cement, yes. It'll be all right.
Oh, yeah. So that's
Okay, stick her down in there.
Phase 2. The mold goes into the plaster.
I think there's going to be like fire or flames or something that he's burning this stuff from, and we don't want to get burned from it, so we're wearing this stuff.
What we're doing is we're taking some silicon bronze and we're melting it down at about, 2100 degrees Fahrenheit. And the first pour.
Phase 3. The molten metal goes into the mold. Solid, liquid, solid.
Okay.
Solid, middle, solid, liquid, solid. You go, stop.
Look what we've got. Oh, yeah.
Let's get some hot dogs.
A solid sits on its stand. A liquid flows and runs out of my hand. There's a gas in this balloon. Now it's in the room. Science.
When matter's in the gas phase, it takes the shape of its container. When matter's in the liquid phase, it takes the shape of its container. When matter's in the solid phase, it holds its shape. Many solids hold their shape even when you hit them with a water balloon. Well, you know what I mean. Gases, liquids, solids, science.
liquid and solid. We got a clue from some famous scientists. They took a look when the water turned to gases. Then they conclude everything is made of matter. Small particles, just take a look around. Change temperature, then the elements transform. It warms my brain to think of all of that change. Just take a look, form a shape or rearrange. This was so cool that they finally formed a theory. The elements formed are solids, liquids, and gases. Some elements, when combined with other matter, make such a change that they stay that way forever. Some other things change from one form to another when temperature is made hotter or cooler. All molecules moving slower or faster cause elements to change their form of matter. The ocean and the air are made of molecules together all the time, often changing rules from solids, liquids, gases. We have learned all that matter is to life, what beat is to rap. Cause it's cool right now, it's hot right now, it's gas right now, it's liquid right now, it's solid right now, changing phases right now. And I'll tell you now, science is cool right now. It's cool.
And action. Bell. Bell! Oh, excuse me. Just doing some cooking, you know, changing some phases of matter. Right here I've got a solid boiling in a liquid, and I'm getting a gas. Well, thanks for hanging out with me today, but right now I got some serious phases of matter to change. See you around the universe.
Produced in association with the National Science Foundation.
Well, got some phases of matter to change.